Hello everyone, my name is Mohammad Hujaifa Islam and today I'm going to give a presentation about our work titled Generation of Clothing Items with Jamdani Motif Element using Automated Generative Adversarial Network. My teammates are Samiur Rahman Abir, Mohammad Sakibur Rahman, Hasan Mahmud and our supervisor is Professor Mohammad Shafiul. Here are the contents that we are going to discuss throughout this presentation. At first, introduction. Jamdani is a traditional weaving technique from Bangladesh that produces intrinsic pattern. It's a very old form of art that we typically see in traditional clothes like shari, Punjabi, katha. But our goal is to take this traditional art and put it into modern clothing items so that it can inspire designers to create even more clothing with this traditional art form. Our objective is to use the conditional GAN and neural style transfer algorithm to infuse this pattern into blank modern clothing templates. We believe our work can contribute to preserving this old traditional art form and it can push modern fashion design. There are a lot of literature review done for this purpose, but today I'm only going to talk about two papers that directly help or inspire us. At first, we have Jamdani motif generation using conditional GAN. In this paper, they have used conditional GAN to generate different types of Jamdani pattern, and we use these patterns to create our clothing items. Next, we have cloth GAN generation of fashionable Danhan clothing using generative adversarial network. Their work is pretty similar to our, but rather than using Jamdani motif pattern, they have used Danhan dataset. We have also taken huge inspiration from their evaluation metrics. Now let's talk about our datasets. We have used two kinds of dataset for our work. At first, we have fashion image dataset, which is a public and open dataset with many different kind of clothing items like pants, t-shirts, shoes, bags, etc. Second, we have the Jamdani motif dataset, which we have taken from the conditional GAN model I've discussed before. As it is a conditional GAN model, we can generate as much as Jamdani motif pattern as we need for our purpose. Now, let's talk about our methodology. This is our flowchart of methodology. Here, at first, we can see we will take the fashion image dataset, resize it, sharpen the image, and normalize the pixels to create the training dataset. Then that training dataset will be passed on to our conditional GAN model for training. It will train the conditional GAN model and output modern clothing items. These clothing items will be used as the content image for the neural style transfer algorithm. On the other hand, we have the Jamdani motif dataset, which will pass on to another conditional GAN model, which will give us different type of Jamdani motif patterns. But these patterns cannot be directly infused to the clothing items. So at first, we need to duplicate them along both axes, resize them, and then finally, we'll have the style image. We will put the style image and content image into the neural style transfer algorithm, and it will produce an output which have a clothing item with Jamdani motif pattern. But as we can see from this image, the background is also infused with the pattern. To remove the background, we take the original generated image, pass it along our image segmentation module to get the mask, and use this mask to remove the background. Then the final desired clothing image is used for evaluation. This is the architecture of our conditional GAN model, which is similar to any kind of conditional GAN model. Here we have some noise, which we pass along conv2d transpose to enlarge it to create or generate an image. Then that generated image is evaluated using the discriminator model, which uses a typical convolutional network. Here we have the labels to control which type of image I want to produce. Here are the hyperparameters that we have used for our conditional GAN model. And this is the sample output that we get from the conditional GAN model. Now let's talk about the Jamdani motif generation with conditional GAN. As I've said earlier, we did not create or train this model. We only took the output from this model. And from the output, we can see that it can generate many different unique type of patterns. To expand this pattern, we can use many different type of techniques. One of those techniques is shown here, where we can duplicate this image along both axes to create a grid of pattern. which we will use to create the desired image. Now let's talk about the neural style transfer algorithm. Here we have used VGG19 pre-trained model for feature extraction. We have used this model to extract feature from the content image and the style image and concatenate them together to create the final image. The final image will have the content of the content image and the style of the style image. Here are the hyperparameters that I have used for the neural style transfer algorithm. This is the output from the neural style transfer algorithm, and as we can see, the background is also infused with the pattern, and we have to remove the background. To remove the background, we have used image segmentation. We are using OSUS image segmentation, not any machine learning model for this purpose. So after using this algorithm, we will get a mask, and we can use this mask to remove the background. Now let's talk about our result and analyze them. Here is the final output that we get from our model. And if we zoom the result, we can see that each of these image has unique type of patterns in them. And if we change the technique of pattern expansion, the output will also change depending on the technique, which we can see on the right hand side. Now let's talk about our evaluation. We have used two types of evaluation, quantitative measure and qualitative measure. Here are the scores of our quantitative measures. And here are the score of our qualitative measures. We have asked 150 people different questions, and from the survey we can see that our model can output visually appealing images, realistic images, images that match the size of a real image, and unique patterns. It generates clothing items, which is something people would wear, but they do realize that this image is generated by a machine. And finally, 83% of people agree that this can definitely help designers or inspire them. Finally, let's come to the conclusion. Designing clothes is a very challenging task that combines practicality and artistry, and our work here is to automate this artistic process by using machine learning. And from our evaluation, we can say that it can definitely help and inspire designers to make more unique clothes. There are some limitations in our model which I will discuss in the little section. There are some shortcomings in our model. The image quality is not very good enough. The output cannot be directly used for usable clothing items. A little portion of the pattern is blurred for some reason. The patterns are not localized, they're spread all over the clothes, and the generated image are grayscale image, not RGB image. We do plan to do some future work on it, like localize the pattern so that we can put the pattern on a specific part of the cloth. The pattern is more clear and sharp. We want to make a 3D image. We want an RGB image rather than a grayscale image. And finally, we want to create a web application so the designer can easily use our model. These are the references that we have used. Thank you for your patience, and that's all.